In this video, we will learn how to compute probabilities of draws with replacement. An urn contains 8 pink and 7 red balls. 4 balls are randomly drawn from the urn in succession with replacement. That is, after each draw, the selected ball is returned to the urn. What is the probability that all 4 balls drawn from the urn are red? Round your answer to 3 decimal places. So what we have is 8 pink and 7 red balls. They're randomly picked one at a time, and whatever ball we picked goes back into urn and could be picked again by chance. There are a total of 15 balls in there. We would like to compute the probability that all 4 draws happen to be red balls. Because each time we pull out that ball, that new choice is independent of a previous choice or the choice that comes after, we are dealing with the multiplication rule of independent events. So this probability of all 4 are red could be expressed as probability of getting red and then red again and red again and red again. Because events are independent, it means we have a product of probability of red times probability of red times probability of getting a red, and fourth time the same thing. It can be written in a shorter way as probability of red raised to the 4th power. What is the probability of getting a red ball? Well, there are 7 red balls out of 15 balls altogether, so 7/15 is the probability of pulling out at random a red ball. Raise it to the 4th power because we repeat this same draw 4 times, and a number rounded to 3 decimal places that we get is 0.047. So the probability of this event is less than 5%. Here are 2 more examples, and both of them are involving a fair die. A fair die is rolled 4 times. What is the probability that a 4 is obtained on at least one of the rolls? Round your answer to 3 decimal places. So we're looking for the probability of getting at least one roll with result of 4. This is quite a complicated event because it includes several options. It includes the probability of getting a 1 of the 4s, or 2 of them, or 3 of them, or all 4 of them. So computing probability from this perspective can be a difficult task. Instead, we can look at this problem using the complement rule. What is the complement event to the one we are working with? Getting at least one roll to give you 4 has a complement of not getting 4 at all, not even once. So we can compute the probability we're looking for by saying, let's subtract the probability of the complement event from 1. 1 minus probability of none of the rolls producing 4 is equal to 1 minus 5/6 raised to the 4th power. Let me explain where this comes from. If we're not getting 4, it means we're not getting one option out of 6 altogether options. So we could, when we roll a die, we could get any number between 1 and 6. Since we're interested in getting anything but 4, it means there are 5 options out of 6 available for that to happen. And because we're rolling 4 times, we raise this probability to 4th power. When you use a calculator to compute this quantity, a number rounded to 3 decimal places should be 518 thousandths. Next example. A fair die is rolled 5 times. What is the probability of having no 1 and no 4 among the rolls? Round your answer to 3 decimal places. We are looking for probability of getting no 1 and no 4. It means that we're okay with getting 2, 3, 5, or 6 on all of those 5 rolls. There are 4 possible options out of 6 available, so 4 out of 6 is my probability of getting any of these. Since I'm doing it 5 times in a row, I raise this quantity to the 5th power, and the result is 132 thousandths when rounded to 3 decimal places.